Hi, how's it going, guys? I wanted to go over real quick the notes about midpoints and bisectors. Oh, man. Awesome. All right, here we go. So today's notes, we looked at notes on midpoints and bisectors. So the first section of notes really is just like a brief overview of a lot of things on this subject. So taking a look at a line segment, okay? You can have multiple letters on a line, and it can have multiple names, okay? And they all mean the same, well, sort of same thing, depending on how you're looking at it. But this line could be called AB or AC or even BC, and they all kind of mean the same thing. But if I said something like AB specifically, that's just that little section right there. AC would be the entire section, BC would be that section, but they all fall in the same line, okay? It's going to be kind of important later talking about another word. Okay, midpoint is when you have multiple parts to a line, and you have one specific point which cuts it right in half. Okay, so it puts this side equal to that side, and we use a little marker, little small slash to go down that line to show that this piece is equal to that piece. Okay, that AB, line segment AB, is equal to line segment BC. Okay, B is the midpoint of AC. Okay. If you had a square or a rectangle, you could use those little slashes, which we will later, to show which sides are equal. So you see here on a square, they're all the same side, so you can just put little slashes around every side, and that shows that each one is equal. On a rectangle, however, we know very commonly with a rectangle, the opposites are the same. Okay, the opposites are the same. You can do one slash and two slashes to show that. All right, next one here is about angle bisectors. Okay, you can take an angle and cut a line down the middle, and it cuts it in half as well. And very similar to the lines, you put a little angle, like a little half angle thing, like a little part of an arc, like a little part of a piece of circle, and then do like a little line slash through it to show they're equal. Okay, even if it doesn't quite look equal with the notes there, you're basically saying that they're both like 20 degrees or 30 degrees or 40 degrees. That little slash right there, that little slash through it. This one is equal to that one. And you can kind of have multiple angles and do it like this too, where you have multiple angles that are the same. Some more vocabulary, okay? There's the small angle, there's this other small angle, then there's the overall bigger angle. Okay, they're all different angles. So this with three lines creates three different angles. That point where they're all meeting is called a vertex. Okay? A line, it's like a line segment where it has two ends, right? It's got some endpoints to it. When you have a line with only one endpoint, we call that a ray. Think of like a sun ray. Okay, it starts here and it goes out one way. It's called a ray. We could call this big angle. If we had an angle like this, we could call it either ABC or CBA. But most importantly, the vertex point is always the point or the letter in the middle. So I could call this ABC. Looks nice. Or CBA, which might not be as pleasing because it's like ABC backwards, and that might not be like, it's kind of weird looking for you. I usually write it ABC, but if you wrote it angle, CBA, you wouldn't be wrong. Okay? And then something else about angles before we go on to the next section. We have what's called complementary or supplementary type of angles. Okay, it's when you have two angles. Two angles are complementary if they added 90 degrees. Like 45 and 45 are complementary. 50 and 40 are also complementary. 30 and 60, 70 and 20, 80 and 10, and all the other numbers in between. As long as those two angles add up to 90 degrees, they're considered complementary. Supplementary are angles that add to 180. So 180 or 90-90 or 75 and 105. Okay, any two angles that add together to 180, that's what supplementary angles are. Okay, and that's kind of the way that we show supplementary. And that's how we show that they're complementary. The way I remember it, these angles come up a lot. Okay, 90 and 180, we hear those a lot. So which one's which? Well, 90 is a lower number than 180, and the letter C comes before the letter S in the alphabet, so it's like alphabetical order. So the first letter in the lower number, second letter, and the second or higher number. That's kind of how I memorize that. Okay, next we have some other ideas we want to look over before we go into the examples, and that is what is congruent. Okay, So congruent is this idea of same size and same shape. Okay, so same size means two things that have the same area. So let's say both these shapes, which they're not the best drawn shapes, but if both those shapes had the same area, they would be considered equal. Okay, had the same size, meaning if I had like paint and these were pieces of like wood or something, and it took the same amount of paint to paint each one, then they'd probably have the same area. They'd be equal in size or maybe equal in weight. Okay, if they look the same, like two squares, okay, they have the same shape, we call them similar. So think about like a model car, looks exactly like a real size car, but it's just scaled down. That would be a similar shape. The two squares that have the same shape but different sizes, they're called similar. So if two things have the same size and the same shape, we call them congruent. Okay, we're mixing the equal sign with the similar sign to create this congruent sign. It's an equal sign with like a little squiggle on top, and that squiggle starts at the bottom, goes up, and then back. Or that goes up, down, back up. Okay. And then these two last terms, there's collinear and coplanar. Collinear is when you have points or line segments that are all on the same line, collinear. And coplanar is when you have multiple points or lines or figures or drawings on the same plane. So a plane is, think of like a piece of wood, like a piece of paper, like a two-dimensional thing. Okay, they're on the same plane. It's a little difficult to visualize until you get something like a three-dimensional box. Okay, take a look at this three-dimensional box. I kept this just for geometry lessons. Okay. Like all these pictures and words are on the same plane. All these pictures and words are on a different plane, but these are all on the same plane. These are all coplanar. All this stuff, coplanar as well. This stuff, coplanar. And then even like the bottom, okay? That's all coplanar. But this stuff is different than this stuff with this stuff. So when I draw this picture of like a square, this is like a plane, just some space, and these things are on that same space. But if I turn this to three dimensions, right, where this is like a square, but it's honestly, I could look, there's dimensions 1, 2, 4, plus the bottom square, which is 5. This has 5 planes on it. Okay. All right, so I'm going to make another video for the 2 examples that we went over today that will help you with your classwork. Okay. So those are the notes on midpoints and bisectors. Hopefully that makes sense. I will upload those documents so you can get a better view of it. Yeah, so if you need to copy those notes down, if you missed the lesson or didn't get a chance to copy it down, or your dog ate the work, you can always go and recopy those. I will post those on the Canvas page. Okay, have a great day.